Alright, so we're starting off our notes with this unit title page. Make sure you glue this in. It's a very good tool to keep you organized, especially whenever you're about to study for your test. You can go back in and make sure that you're on the right unit and go to each specific lesson to help you review. So we're starting off this year with Unit 1, and the title is Linear Expressions Equations and Inequalities. Excuse my handwriting. I'm trying to write on an iPad and it's not the best. So our first lesson is, instead of page number, we're just going to do lesson numbers. And so this is lesson 1.1, and it's going to be called Polynomial Vocabulary. Alright, so take just a second, write that down, and we're going to move on to the notes page. In the activity you just did, you had to sort different types of polynomials, and you may not have known it or not, but now you do. You can separate polynomials by the number of terms that they have. So let's start off with these two definitions. The first one is an algebraic expression, which is a generalization that is a combination of variables, numbers, constants and coefficients, and operators. I know that sounds super confusing, but it's really not too bad. Remember, variables are just letters like X, Y, Z, numbers, and then operators are like multiplication, division, addition, and subtraction signs. So an algebraic expression could be a polynomial. And the definition of a polynomial is a monomial or the sum of monomials. So let's take a look at the different polynomials that you just looked at in the activity. The first polynomial is called a monomial. And the root word of that is mono, which means one. So the definition of a monomial is just a one-term polynomial. And what we mean by one term is that all of the numbers and variables are being multiplied together. So it's just one term all together. The next type of polynomial is a binomial. And the root word of that is bi, which means two, like a bicycle has two wheels. So a binomial has two terms. And we can see in this example that this is two terms. The first term is 4x squared, and the second term would be negative 9x. So now I'm separating these two terms by a minus sign. Let's move on to trinomials. The root word of that is, or the prefix is tri. So a tricycle has three wheels, so a trinomial has three terms. In this example, my first term is 2x cubed, then negative 3x squared, and then positive 2. So because I'm separating the first term with the minus sign and the second term with the plus sign, I have three separate terms. I'm not multiplying everything together like in a monomial. I have the separation with addition and subtraction to create these three separate terms. Okay, so let's talk about the degree of polynomials. The degree of a term is the sum of the powers on the variables in the term. So when we're talking about powers and degrees, we're really just referring to the exponents. And if there's more than one variable in a term, you have to add the sum of the powers on those variables. And then the degree of a polynomial is the same as the degree of a term in the polynomial, but we're looking at the highest degree, and that would determine the degree of the whole thing. So let's look at these examples. Go ahead and mark out this middle section. Let's start with -5. So -5 is just a number. There's no variables. And since there's no variables at all, the degree would just be 0. But in the next example, we have two separate terms, a 3x and an 8. Since the x is a variable and it's raised to the first power, remember there's like an imaginary 1 here. This is really x to the 1. The degree of this polynomial would be 1. In the next example, all of this is one term, but I have two separate variables. I have an x and a y. So go back to the definition of the degree of a term, and we have to add the powers together. So I have a power of 3 on the x and a power of 2 on the y. So I would add those two together, and the degree of the entire term would be 5. You only do that if you have more than one variable in a term. Okay, the next example, 4x squared minus 9x. So my first term is 4x squared, and my last term is -9x. I need to determine what's the highest degree of each term. So the first term has a degree of 2 because it's x squared, and the last term has a degree of 1 because it's x to the first power, or x to the 1. So since 2 is greater than 1, the degree of the polynomial would be 2. And then this last example, I have 2x to the 4th minus 3x cubed plus 5x. So I need to find the highest degree, or the highest exponent of each term. I have an x to the 4th, an x cubed, and then an x. So the highest degree would just be 4, since that's my highest exponent in each term, or of that term. Okay, something to keep in mind is always write polynomials in order from highest to lowest degree. So maybe you have a polynomial that looks like this, x plus 2x cubed minus 4x squared. We need to write this in correct order. So I want my highest degree first, which would be the x cubed. So I would rewrite this as 2x cubed. And then my next degree would be x squared. So this would be minus 4x squared. And then finally the x. So as you can see, the exponents go in order from highest to lowest. So we just want to make sure that we always do that whenever we're writing our polynomials. Let's move on to the next page now. Alright, we're going to go ahead and model some polynomials with algebra tiles. So if you don't have them, go ahead and get them, and you're going to have to share with your table partner. Let's go ahead and review what each of these represents. So these little units are 1 and -1. The red side is going to represent the negative side. The longer rectangles are x and -x. And then finally, the bigger squares are x squared and -x squared. And we get that because if I took one of these skinny rectangles and put it along the length and the width, if I multiplied this x times this x, length times width gives me area, x times x would give me x squared. So that's where these tiles come from. Okay, so I want you to model this polynomial, 5x minus 3. So this really means 5 x's and 3 -1's. So let's take out 5 x's. So I would have 5 x's. And you can put a little x in here if you want to. And then I have 3 -1's. So I need 3 of these little -1's. Alright, so this is an example of what 5x minus 3 would actually look like. Sometimes in algebra, whenever we do problems, you're like, I have no idea what x or 1 or x squared means. But whenever you use Algebra Tiles, it actually gives you a visual representation of what that could look like. Okay, I want you to try to do the next one on your own. So you have 2x squared, 4 negative x's, and then 3 1s. So take a little bit of time before you draw it, model it with your Algebra Tiles, and try to show what 2x squared minus 4x plus 3 would look like. Alright, let's look at it together. So if I have 2x squared, I would need 2x squared. So I would need 2 of these bigger squares. And then I have 4 x's, but they're negative. So I need to turn them around to the red side and get 4 of those. So I have 4 negative x's. And then finally we have 3 1s. So I just need 3 of these little 1 units. And this is a representation of what 2x squared minus 4x plus 3 would look like. Okay, now what I want you to do is you're going to create your own using Algebra Tiles, and then your partner is going to write down what that would be as an algebraic expression. I'm going to do one as an example. Do not write this one down in your notes because you're going to save your section C for your own. I'm just showing you an example. So we're actually going to go backwards. Now I'm going to start with the picture, and then as a class I want you to guess what the expression is. So here's my picture. Okay, if you need to pause the video, I want everybody to write down somewhere either below or above or on some scratch paper what you think this expression would be. And then I'm going to write the answer, and if you get it right, you can get a ticket. Okay, so write down what this would be as a polynomial expression for this picture that I drew. Okay, you should have gotten negative x squared plus 5x minus 4, because I have 1 negative x squared, 5 positive x's, and 4 negative 1s. So good job if you got that correct. So now what you're going to do with your table partner is the same thing. Just take out your Algebra Tiles. I want you to create a polynomial, and then your partner is going to guess what it is and write it down as an algebraic expression. Alright, that's it for the notes. So now you're going to start your worksheet, which is called Practice 1.1 Polynomials, and this is going to be due Friday. So make sure you don't procrastinate and wait till the last minute. Start working on it now, and if you have any questions, you can call or text me. You can send me pictures of problems, and I'll respond as best as I can to try to help you. Hope you guys have a great day, and I'll talk to you later.